going to talk about signal crayfish and the River Avill. And you'll probably think, well, what's that got to do with eels? But you're about to find out. Is anybody local to the Avill? Oh yeah, quite a few. Jolly good.
There are volunteers to be, Nicky.
Yes, Pat has got a sign-up sheet, so if you're interested in doing some volunteering on crayfishy, eely type stuff, then do get in touch and sign up. Can everybody hear me okay? Yeah. Right, so we're talking about signal crayfish. Where did these creatures come from? So they appeared in the UK in 1976. They didn't appear, they were introduced deliberately in order to basically make money. So in Scandinavia, crayfish parties are very popular, and people eat a lot of crayfish there. So they put on silly hats and they eat vast piles of crayfish and drink gallons of schnapps. And the Department of Agriculture back then thought that they would be able to kind of get English people eating mountains of crayfish and drinking gallons of real ale or something, and buy lots of crayfish, and it was all about sort of diversification of farming and just improving the economy. So these crayfish, they were introduced into 300 sites, so farmers' ponds, rivers, commercial fisheries, a wide range of sites, and they basically got out. And you can see from the maps here. So the top one is the distribution of our native crayfish, white-clawed crayfish, in prior to 1975. And then jumping forward to 2009, you'll see that the white-clawed crayfish has virtually disappeared, and all the red blobs are catchments that have been invaded by signal crayfish. And obviously the situation is much worse now, 15 years on, 16 years on. And it's a pattern that's all over England and Wales and into Scotland as well. So what do these things look like? The first thing, the bottom left photograph, you see the white patches on the tops of the claws. So that's why they call them signal crayfish. These white patches are the signals. And you can see up here, even if you see a crayfish walking around in the river, you can identify it by those white patches, so you can see what species it is. A small caveat with that is that the very small crayfish, these spots aren't that obvious, but once they get to about sort of 3 or 4 inches in length, they're very easy to spot. And the other thing is they have a bright red underneath of their claws, and they burrow in the banks. So the top left-hand photo up here is burrowing in the banks on the River Barle. So they create these low burrows like a flattened D shape, which are quite distinctive. Ecology. So they're a decapod crustacean. They have 10 limbs. That's 8 legs and 2 claws, also called chelae. And they grow quite fast, and they can live up to about 12 years in the wild. Every year the females will produce between 100 and 400 eggs. They mate in the autumn, and then the females will carry the eggs under their tail or their abdomen. Oh, press the wrong button, sorry. Here, so they're carrying the eggs here. That's when they call them buried females. And then they hatch on the female and disperse between about March and June. It's getting earlier all the time because of climate change, so I've had reports of crayfish releasing their eggs in February this year. So they have it gives them an advantage over the other crayfish species. And they're they're not nocturnal, but they're more active at night. And also in the summer, so they're cold-blooded, so they're less active during the winter because they don't have so much energy from the sun. And they shelter in the river's substrate, so they'll bury into the substrate between rocks, underneath rocks. One of the survey methods we use is we literally look underneath rocks. They'll use things like tree roots and undercuts, and then they will burrow extensively as well. They're omnivorous, so they'll eat pretty much anything, and that means that they're called keystone species. So that means that they can have an effect on every level of the food chain, so from sort of predators right down to detritivores. And they're quite aggressive. You can see quite an aggressive one, bottom right, and they're quite exploratory as well. So they're more likely to spread, to expand, because they do tend to sort of move around quite a bit. And the impacts of signal crayfish. I've already talked about the white-clawed crayfish. So they've wiped out the white-clawed crayfish by probably 90%, 95%. It's in the same kind of state as the European eel, really. And they've done this by carrying a disease called crayfish plague, which completely wipes out white-clawed crayfish but doesn't affect the signal crayfish. But they also will outcompete them through, basically they're better at being crayfish. So they grow faster, they produce more young earlier in the season, they're much more aggressive. So there's all these reasons why they're better at being crayfish than white-clawed crayfish. And this goes back to really where they evolved, because they evolved in the USA, northwestern USA, western Canada, and there are 60 odd other species of crayfish in that area where they evolved. So they've grown up competing with other crayfish species, so they had to be good at being crayfish. And whereas the white-clawed crayfish, there's only 5 other species in Europe, so they've had quite an easy time of it, really. The other thing that signal crayfish do is they'll have, as I said, effects on the food chain. So they can predate things like salmon fry. They'll eat invertebrates. They'll eat vegetation. They'll eat detritus. They compete with things like bullheads. So this is the bullhead. And the thing here that looks like a kind of a little stalactite is the bullhead's eggs. And so, you know, the signal crayfish will come along and pounce on the bullhead and munch it, and then go work its way through the eggs, and then go and live in its little house as well. And then the burrowing can have major impacts as well. So you can see this is again on the River Bar, some serious erosion that's been caused by extensive burrowing. And what happens is it widens the river, the banks get eroded, the river widens, it dumps a load of sediment, which is not good for things like salmonid fish. And then it also slows the rate of the river because the river has become wider. And then that exacerbates the whole problem with the siltation. And it can lead to flooding as well. You know, in some parts of the country, there are sort of major flood issues caused by all this sedimentation from crayfish burrows. Now, I'm just going to talk briefly about population structure. So, a crayfish population is about 80% small crayfish, less than 3 inches long. How many people have seen a signal crayfish? How big was it? Yeah, so they make up about 5% of the population. For every crayfish you see that's that big, there's going to be 20 or 30 very small ones that not only you never see, but also are very difficult to catch. Well, if you're a human, they're very difficult to catch. So I'm going to move on to how we've been trying to control sigma crayfish. And there have been a lot of methods that people have tried. So some examples include biocides, so insecticide, pesticides. You can try dewatering the river, then removing all the animals. Electrofishing has been trialled. Sterilisation of male crayfish. I'll talk about a little bit about that in a minute. The use of barriers can be beneficial, and then predators can also be beneficial. You could probably guess where I'm going with this now. But all of these methods have got limitations, and there is no basic successful method that has been developed that works on rivers. Rivers are particularly difficult compared to still waters because they're open, so the crayfish can spread. And if you've got a large population over a large amount of river, the resources needed to try and tackle it are just phenomenally expensive, and it's really not feasible. And going back to my slide with the graph about the sizes, you need to target all of the crayfish. You need to be able to do something about getting rid of the tiny crayfish that you can't actually catch as a human. And so it can be incredibly expensive and futile, but there are opportunities to work with natural processes and natural features within a river that could help you. So one of the most commonly used methods is trapping or removing crayfish. So the main types of traps that we use are these traditional funnel traps, and we put bait in them and we leave them overnight and we check them every 24 hours. This is basically a habitat-based trap, so it mimics the refuges that crayfish might look for, so a safe crevice within rocks or a burrow, things like that. So they will readily go into these, and these are very good because you don't have to check them regularly, and they catch an equal sex ratio and a reasonable range of sizes. So it'll catch sort of medium, small crayfish a little bit, whereas the funnel traps tend to be biased towards larger animals and particularly males. And then you've got things like nets, fyke nets, other nets. You've got the sort of looking for animals by searching through the substrate. And then also you can sort of use dewatering as an aid to remove crayfish as well. So that's sort of removals. And again, what you can get is you can get density dependent effects. And what that means is if you take out all the large animals, because large crayfish are cannibalistic, so they eat small crayfish. So if you take out all the large animals, what you can get is either no impact on the population, or you can get a population increase because all of the small crayfish are no longer being restricted by the fear of being munched on by the big crayfish. So they're more likely to be able to find mates, they're more likely to survive, they'll grow faster, all that kind of stuff. Predators are a useful thing. So there's quite a few different things that will eat crayfish. We've got perch, we've got eels, we've got otters, even kingfishers will eat those little tiny crayfish. They're quite good at catching crayfish. And also, even the presence of fish within a system can have an effect on the population, because they sort of interfere with the crayfish, so the crayfish will avoid areas where fish are, they'll get disturbed, it might affect how much food they eat, how much time they spend looking for mates, things like that. So the best predators, surprise, surprise, are, well, perch and eel. So perch are a very good predator of crayfish, but they're not locally native to the southwest, and they can be quite invasive, so you can't introduce fish into a river, particularly not a river on Exmoor. Eels are great. Eels are the best predators. What studies have found is that fish are limited by their gape size, so the size of their mouth. And that means they can only eat the smaller crayfish, so the small ones that we can't catch, small to medium-sized crayfish. We can catch big crayfish, so humans can catch big crayfish, fish can catch little crayfish. So there have been studies whereby they have manipulated fish populations in order to increase the amount of predation of small animals, and then alongside they have trapped the large crayfish, and that has led to complete decline of the crayfish population. And then what happens, if you're lucky, is that the predators that have been introduced will maintain that population at a low level, and we call it a functional eradication. I mean, the idea of eradicating a crayfish population is really unlikely to happen, but you get this functional eradication where you reduce them to such a low level that they don't cause these adverse impacts and they don't spread. And so why eels? Why are eels the best predators? They're nocturnal, they hunt at night. That's when the crayfish are active. They hunt by smell, so they can find a crayfish under a rock or in a burrow. They can go to a burrow and they can sniff them out and they can get them. They're really good. And anecdotally, all of the places where signal crayfish have been introduced, the only examples where they have not massively taken hold and expanded have been in rivers where there are good populations of eels. And so the idea is that you manipulate your predator population and you remove crayfish using trapping, and that is an effective control method, and it's been proven. And so my idea is, of course, well, we can help to save the eel, and they can help to get rid of our crayfish. No idea what's on the next slide. Oh, this is just an example. Now, the other thing I was going to say was, no one has tried to do anything with introducing eels or improving eel numbers in a river anywhere, I don't think. Because the assumption is it's an open system, so the eels will just scarper. So you've got no way of keeping them where you want them, where the crayfish are. And so I think everyone has said, well, they won't stay where you want them. But a Loughborough University, a PhD study, actually sort of looked into this. And what they did is they selected a stretch of river with a weir at either end, and they put 109 tagged yellow eels in, so there's sort of the intermediate size, and they put tag readers on each of the weirs, so if the eel went over the weir, there would be a ping, and they would know that they'd left town. And they also did some lab experiments at Loughborough University where they exposed signal crayfish to eels and to see how they predated them. And so the results were that the eels did actually stay put. They didn't scarper. Only 6 out of 109 went over the weir and never came back. And they compared it with a control site. And at the control site, the crayfish population increased, whereas at the eel site, it stayed the same. So it's kind of tantalising. They only monitored for 15 months, so that is not long enough to sort of see an impact, but it's sort of a good indication that something is going on. And also, they recorded damaged crayfish. So if the crayfish are being attacked by something, you're more likely to find them damaged, because they will very easily shed legs, claws, etc. So the more damaged crayfish you see, that means the more pressure they're under from predators. And you can see that there were more damaged crayfish at the study site, but not the control site. That stayed the same. And also in the lab, almost half of the crayfish were eaten by the eels within 24 hours, so it's obvious that the eels are enjoying eating the crayfish. But that was the only study, and it's not enough to find out, you know, exactly if we can succeed, but it's a very, very useful sort of indicator that there is potential. The last control method I'm going to mention, because it's relevant to the Avill, is barriers. And so a barrier could be a natural barrier like a waterfall, something like that, or it could be an accidental barrier. So that bottom right photograph, that's a culvert in the Midlands, and it just happens to be protecting a population of white-clawed crayfish, because the signal crayfish down below can't get into that culvert. And then there's potential to adapt an existing barrier. So on the left-hand side, that's an existing weir, which has been modified to prevent signal crayfish from climbing up. And there's also temporary barriers, such as on the top right, this is a crayfish reef. So it's a structure made out of habitat features that that crayfish will use, and it's put in place for a few weeks, and the crayfish will colonise it, and then you go along and you dismantle it, and you take out a big pile of crayfish. We've been playing with that, and I'm going to talk about that in a minute, but I just say that volunteers are really not interested in stomping across the moor carrying a rucksack full of bricks. I don't understand it, but it's just something they just don't want to do. But we've found a way around it, so it's okay. The thing with barriers is that there may be indirect impacts. So you have to make sure that they're still passable by migratory fish, such as eels, also salmon, and also just resident fish. You know, if they're cut off from other sections of river, that could be detrimental. But the thing that you really need for a barrier is you need a vertical drop, an overhang, so the crayfish will go up there and then they go, oh, I can't do that. And also a persistent flow level of 0.65 metres per second if it's just a flow. Right, heading on to Exmoor. I'm just going to briefly describe what we've been doing since 2014, which when I started messing around with crayfish on Exmoor. So we've been doing a lot of surveys. So these are the populations that we have. We've got the River Barl, which is the biggest population that we have, and it's up as far as Simmonsbath now, and it's potentially down to below Dulverton. So we have found crayfish downstream of Dulverton, but we don't know if the two populations are connected, because we've never actually found any crayfish in the Dulverton area, but it's quite likely that they are connected, and so it's one big population going from Simmonsbath to or probably Brushford. And the worrying thing about this is that's the Sherdon Water. Does anyone know the Sherdon Water? Yeah. So that's one of the best salmon spawning streams on Exmoor, and they're up there. And it's so remote, it's really difficult to kind of do anything there, which is a big challenge. Then we've got a population on the X at Exford, going down to sort of Larkham Foot, just upstream of Winsford at the moment. And then there are crayfish on the main X, so they're coming up from the Tiverton area, so they're slowly spreading upstream. The good news is we surveyed the Lynn catchment and found nothing, and we also surveyed the Hadio and found nothing. And then 5 years ago we had a report from of a sighting of a crayfish at Gallocks Bridge. So that's why we have got onto the Avill. Oh, that's the wrong button. I'm just going to talk a bit about what we've done with our crayfish over the last 10 years or so. So after the survey of the Barl in 2014, we started on a project to attempt to control, and we attempted to use a male sterilisation technique. And some of the people here tonight have been doing that ever since, or right from the beginning of the project. And we trapped on a 1.5 kilometre site just upstream of Withypool, and the reason is because the large males, as I said, they eat the little animals and they dominate the mating behaviour. So the idea was, if you keep the large males in the population but you stop them from being able to breed, then that will cause a decline in reproduction and a decline in the production of those little tiny animals that we can't catch, which form 80% of the population. So that was the plan. So we did the sterilisation, and we used 2 types of traps. So the baited traps were predominantly to catch large males that we could sterilise, and then the ARTs, we just wanted to remove as many other animals as we could, including females. And we did it for 7 years. And I also, it was a part-time PhD, so I did my PhD on it, and did various lab experiments on the effectiveness of the sterilisation technique and how it affected behaviour or not. And the good news was that trapping every week for 7 years caused a 60% decrease in catch rates overall. But there was no evidence that the sterilisation technique worked. I'm not going to go into it any further than that, but if anyone's interested, there are papers and my PhD thesis available online. If you want to contact me, I can send you the information. So that took us to the realisation that long-term trapping is over a large area is just not going to work. So we thought, well, what can we do? What are we trying to protect? And you know, the answer is the moorland landscape, the beautiful unspoilt streams, the migratory fish, the salmon, everything like that. So we thought, well, can we do anything to stop them from spreading upstream any further? And so we started, I invented a thing called a containment zone. And it's basically an area near the upstream edge of your crayfish population, and they call it the invasion front, where the upstream edge, where it's expanding. And where we use basically traps and removals and these temporary reef structures to collect and remove crayfish in order to stop them from going further upstream, or at least slow them down from going further upstream. And Pat very, very eloquently called it the pub before the church analogy. So the idea is you put loads of crayfish habitat in, and they're walking up the river and they go, oh, I'll stay here for a bit, I think, and then along we come and take them away. So what we did was we did some work at Exford. We did 2 years trialling a range of different types of trap, and what we found was the most effective way of removing large numbers of crayfish and a good size range was the ARTs, and these are artificial refuge traps, which I showed you before, and brash bundles, so bundles of sticks tied together and put in the river, and then you lift them up and crayfish colonise, small juvenile crayfish colonise them, and so we actually found an effective way of catching juvenile crayfish, which is this brash bundle. And what we also found at Exford was that elvers really like brash bundles as well, and so we thought, oh, that's really interesting, so we can catch elvers as well, and so that can give us an idea onto the populations of eels and the likely interaction with crayfish. And then in 2024 we sort of developed a usable, workable reef design, and we started trialling that, and it's very simple, basically using a combination of the brash bundles and the ARTs. I've got some photos in a minute. And then this year we took that a bit further, and we did a mark recapture trial. So we made 3 reefs along a short stretch of river, and we marked all of the crayfish that we caught with numbers. That's number 120 over there. And then we recorded where they went, the movements, so to see were they being stopped by these reefs? Would they stop at the reef? Would they colonise the reef? That kind of thing. I haven't looked into the data very much, and we didn't get a very large number of recaptures, which was a bit disappointing. But the recaptures we did get, I think 80% of them were found within a reef. So that's encouraging, but more to do really there. And then at Cowbridge, just outside Timberscombe, we set up a containment zone, which is a combination of a barrier, a reef, and some traps as well. And I've got a diagram of that, so I'll show you that in a second. And now we're going to talk about the River Avill, which is a very pretty river. It's beautiful. So, I'm sure there's people here who know a lot more about the River Avill than I do, but it rises on the slopes of Dunkery Beacon, flows off the moor down towards the sea, comes out at Dunster Beach. The whole catchment is around 30 kilometres long, including the tributaries that go up towards Luxborough and Timberscombe and what have you. Overall, it's got pretty good water quality. Good invertebrate populations. It tends to decrease the further down you go because it flows through the village and it flows through more intensive agricultural land. So it's the kind of thing that happens with all rivers. You know, they deteriorate the closer they get to industrial agriculture and human habitation. It's classified under the Environment Agency's Water Framework Directory as moderate ecological status, which is not bad, which is pretty good. It's got a good population of trout, and it used to have a good population of eel as well. I've spoken to people, like Vanessa was talking about eel stories, and you know, a few people have said, oh, we used to see them all the time. I met a lady who, she was about, I don't know, 14. She said when she was a child, she wouldn't go into the pond on her parents' land because it was absolutely full of eels, and it was too scary. And she said she'd walk in and they'd be all over around her legs and everything. And it's also classified as heavily modified, and so the reason it's heavily modified under the Environment Agency is this. This is the flood relief channel, which went in the 1960s, I believe. But really, if you go back another 300 years, it's been heavily, it's been heavily modified. This is an aerial photograph of part of Dunster Marsh, what was Dunster Marsh, which was drained in the 1700s. And if anyone knows the local area, that's Lower Marsh Farm there. And the blue line is the course of the river now. But can you see that amazing meandering pattern of, that would have been such wonderful wildlife habitat back then. So yeah, they started modifying it quite a long time ago. So we surveyed the Avill last year. We wanted to check that it was signal crayfish that we had, not a different species. We wanted to find out the size of the population and how far it extended. And what I found was an absolute first in my career as a crayfish hunter. A low density population of signal crayfish over a short stretch of river. So I immediately started thinking, we might be in with a chance on this one. We might have a chance of doing something positive to control these crayfish. And then the next thought I had was, what has the river got that might be able to help us with that task? So this is a map of our survey area and our population of crayfish. So the numbers are basically the yellow patches are areas that we monitored in 2024 where we found crayfish. And at number 7, which is just downstream of Cowbridge, that's where we stopped finding crayfish. So we thought that's probably our invasion front. And so I started thinking, well, what have we got that might help with our quest to control these crayfish? And of course, number 1, we've got this barrier here, which is called the Bristol Channel. And then at the other end of the population, we've got another potential barrier, which is this weir, which is beneath the road that goes over the Cowbridge Road. And I think crayfish can go over it at the moment. We know they can because we have found one crayfish upstream of that weir. But it's got potential to be modified, I believe. So we think that this area, this bit of the weir is always fast flowing. So we want to log the temperature, log the flow rate and see if it's that 0.65 metres per second year round. And then the rest of it, and then that will provide a passage for the eels and salmon and the trout and such like. And then the rest of it can be, we can fit it with slippery sides and perhaps an overhanging lip and things like that to make it more effective as a barrier. And then the other thing we found was an eel. So I thought, we've got eels as well. So what did we do next? We did some more monitoring. So we started off in February, I think it was, and we started trying to record glass eels and elvers coming up the river. And in the summer, we set up this containment zone idea. We set one up at Cowbridge so that we thought, we've got our invasion front, let's start straight away stopping them spreading any further. And then we selected 6 sites along the crayfish area, and we started monitoring eels at those 6 sites through the summer, using a variety of different methods, because basically if you're surveying eels in a river, the main methods used is electrofishing, which is not really something that someone like me and volunteers are set up to do. And also we looked at the 2 outfalls into the Bristol Channel to see if they were affecting the glass eel's ability to enter the river. And we also did some river fly sampling, so we sampled invertebrates at these 6 sites where the eels were as well, to get an idea of the quality of the food supply for eels, if you like. So what we found was we had very low catches of glass eel and elvers in the spring, so that might have been an indication that they were struggling to actually enter the river. And then over the summer, also very low catches. I think we caught about a total of 12 eels throughout the summer, and only mostly yellow eels, so mostly larger eels which were 2 to 3 years old or older than that. Very few of the elvers, and we should have seen lots of them. When we monitored at Exford with brash bundles, we were catching 100 plus elvers in each bundle. You know, it was, we recorded the number as countless because it was too many to count. And we didn't get any. You know, I think we got sort of 1 or 2 here and there, but nothing. And we did find that all the methods that we tried, our brash bundles came through again, and they were the main method that we caught animals in. And good news was we also caught very few crayfish. So I expected to catch a lot more crayfish than we did. So that again is a very encouraging sign that the population is controllable. And the river fly said it's good overall, and as is typical, as you go near the human habitation and the more industrial agriculture, then it goes down a bit, but it's overall pretty good. So what we're going to do next? Well, I'm just going to show you actually. This is an example of the containment zone. So we've got the weir, we've got 10 traps upstream of the weir, then we've got 10 traps downstream of the weir, then we've got a reef, and then we've got 10 more traps downstream of the reef. So it's quite a kind of an intensive zone of trying to remove crayfish. And the good news is that we caught very few crayfish, and they were all the large adults, which are the animals that are most likely to be spreading upstream. So it's not like the whole population is up there, which is good news. And then these 2 photos are photographs of the reef structures. So just artificial refuge traps in a line across the river, so the crayfish walking up, they're faced with basically a big row of tempting looking holes that they could just go and hang out in. And we're hoping that they're going to be effective. But the good thing is you can do multiple, you know, you could put, very easy to set up, so you could do one every 50 metres for a mile if you wanted to, if you had the volunteers. And then a little bit about the barriers, so the outfalls. So we looked into these, and there's 2. You've got the one at the end of the flood relief channel, so on the left. So this is a stepped weir, which looks kind of scary if you're an elver, but it's not that bad because it's got these channels on either side with water flowing, so they could get up there. One of the problems is the stream flows right across the beach, so you've got a very shallow, open stream across the beach before you get to this barrier where elvers could be very easily picked up by gulls and such like. And then you've got the flood relief channel where the water is only sort of, you know, even in high flow, it's probably no more than about 4 or 5 inches deep. And what we found this spring is that it dried up in March. And so it's not working as any kind of passage for elvers. And it was dry all through the summer as well. You know, as well as the fact that any elvers within that channel would be very exposed to predators because it's shallow water, it's completely open, and it's what, a kilometre or more long, potentially more than a kilometre long. The other one, the other outfall, this one, this is up at the other end of Dunster Beach, and this is not, it's better, but it's not brilliant. So here, again, we've got a shallow stream sneaking across the beach, which is quite exposed to predators, and then into a culvert. So the eels have to go down that culvert, and at the other end of the culvert is this. This is called a tidal flap. The good news is that most of the time it's open. It only closes during very high tides. Elvers tend to migrate at high tides. Going back to the eel regulations, this is an Environment Agency fixture. They are obliged to adapt the tidal flap so that it closes more slowly, and therefore more elvers get a chance to get through before it closes. But the way the legislation is worded, it means that they only have to do it when they're doing something else to that feature. And so it could be years before anything's done, but I have been hassling them and saying, can you flag this up? Come on, it needs to be done. And so, yeah, neither is ideal. So I think this one, no good when it's dry, and this one, woo, the other one, no good when it's wet, because if you've got lots of high tides, the flap's going to be shut. So that explains why we're not seeing a lot of elvers, and it's probably, you have good years and bad years, but it's influenced heavily by the weather. So yes, we believe that is a major problem. So what are we going to do now? Well, basically we want to work with Vanessa and the Sustainable Eel Group, and we want to do eel conservation on the River Avill. Not just the bit where the crayfish are, but the whole catchment, because they would be throughout the catchment normally. So we want to do a whole raft of eel conservation measures alongside crayfish control measures. But the first thing we have to do is get funding. So if anyone's got any, spare cash, the pot's at the back. But yeah, no, we're trying to develop a project and get some funding for it. But we're going to be looking at habitat improvements to help with the survival of the elvers. And we're going to do more monitoring in general. I'm trying to talk the Environment Agency into doing some electrofishing next year. We want to involve people in eel things, in the similar way that Vanessa was doing. We want to set up some tanks in classrooms and go out and talk about invasive species control as well as eel conservation. And then we're going to set up trapping of the crayfish as well as the containment zone. We're going to, crayfish populations tend to have a kind of a core where you've got a high density of animals that are breeding, and then they sort of start spreading out. It's almost a sort of a density dependent effect. So, they get too crowded, they'll start spreading. So if you find that kind of core of the population where the density is the highest, and you hit that, then that reduces their need or desire to expand. So we're going to focus on that area, but also on the invasion core and invasion fronts as well. We're going to keep going on about the tidal flap to the Environment Agency, and we're going to monitor the weir, as I said, and see if we can get that adapted. And yes, if you want to be involved, then you can get involved through the national park. I think that's it. Yes, that's it.
What do you do with the crayfish when you've caught them?
We humanely dispatch them.
And then what? You don't eat them? You don't eat them?
No, I mean we don't catch them in large enough numbers to sort of make any kind of exotic dish really, and they're not great to eat. They're okay, but we also the way the traps that we use, we catch smaller animals as well. So again, they don't have a lot of meat on them, and they take a lot of preparation. So
they're a delicacy in France.
Yes, so they say, and in Scandinavia.
Yeah. It's an awful waste.
Well.
Nicky, can I just ask about
Sorry?
what starts the crayfish population? What's the feasibility of viable eggs being carried on wading birds, for example? How do they get there in the first place?
It's unlikely because the eggs are attached to the female.
Right.
And I mean they can hatch away from the female, but they're more likely to be eaten by something or to be affected by sort of fungus and things like that. So it's really the animals themselves being spread rather than the eggs, because they all stay, you know, on the female, and they hatch on the female, and then, you know, it's 2 weeks after they've hatched, then the young will disperse. Any more
Nicky,
questions?
just asking,
Yes.
obviously you've got a way to go in terms of this particular project, but the location, I just wonder whether you're seeking to take into account the large pond stroke lake that lies between the two outfalls.
Yes, we've got a good relationship with the owner of the chalets there. He's never said that there are crayfish present. We haven't surveyed for crayfish any lower than Lower Marsh Farm at the moment. It would be very interesting to see if they're in the lake, but I would have thought they would have told us, because they were very interested and very accommodating. But we know that they're sort of down to the back of the housing estate, you know, down to the station. But yes, we'll probably try and do that if we get the funding. Yeah.
If you get funding for putting the eels into classrooms, where are your babies going to come from?
They'll come from Vanessa. From the River Parrot. Parrot? Yes.
So they don't have to be specific to a certain river. Because I was watching a fishing programme and they were trying to restock, I can't remember if it was salmon or trout, but they would only spawn in a certain stretch of the river they came from. They couldn't introduce them throughout the river, they had to be from a specific area. Do you know if the eels are the same?
No, they're not. I think it's assumed that they are, because, you know, of this life cycle where they come all the way across the ocean and then they go up the river. But actually they float across the ocean as larvae, so they basically float, and they don't have any instinct to go to any particular place. I think today they'll sort of opportunistically try to get into whatever watercourse they can. And for example, if they're trying to get into the Avill and they can't, then they'll go on to the next river. And I was told by the Environment Agency Fisheries Officer that all of the other small rivers along that stretch of the coast have good eel populations, because they don't have these barriers. Yeah.
What's the desire for the environmental agency to get involved and really make a difference? So I get from what you're saying, you're trying to always persuade them, as opposed to them actively and proactively really wanting to do something which they should be obligated to do.
They are, I think the EA are very, very widely criticised, but from working with them for the last 20 years, I know what they've been through, and you know they've lost like 60% of their staff. They're basically slowly and surely being kind of cut off at the knees, and there's so many things that they used to do and want to do, but they just haven't because their funding has been cut. You know, their staff has been cut, and also in in these times of climate change, flooding, flood prevention. That is, that's the number one priority. And so, yes, they don't do enough, but I know why they don't do enough, and it's not deliberate, should we say? But but I think if you badger them for long enough, and you find someone who's keen and has got the time to listen to you, then I think you can try and get things done. Yeah. Okay, well, wonderful. Thank you ever so much for coming. I hope you found it interesting.
Yes.
Excellent.
Before people head on, I'll just say I'll email everyone in the next few days to say thank you for coming, and if you reply to that email, I'll assume you want to volunteer. But if you are interested in signing up to volunteer, then reply to that email or one of the others that I've sent you over the since you've booked on, and we'll start the process of getting you helping where we can next year, depending on what happens. Thank you very much, everyone, and thank you to Vanessa and Nicky for doing the talk.